Hi, welcome to this tutorial. I'm happy you're here. So, as simple as it may seem, knowing when something is either on or off can be a great tool to designing something useful. So, answers to the following questions are what this lesson plans to tackle. Is a button being pressed? Has a switch been turned on? What is the status of my on-off sensor? So when you can answer questions like these, then you can implement actions based on that current status. So, for example, if a button is being pressed, do this. Otherwise, do that. Or, if my sensor is active, take this action. Otherwise, don't do anything. So I think you kind of get the gist there. But before we can implement the actions, we have to be able to track the status and the changes on the digital pins. So this tutorial is primarily going to cover the function DigitalRead. We're going to talk a lot about DigitalRead, but we're also going to begin looking at the serial library, talking about serial communications, which is your Arduino talking with your computer and vice versa. Okay, so let's go ahead and jump into this lesson. For this tutorial, you're going to need an Arduino board. I have the Arduino Uno here. You can use any Arduino or clone. I do highly recommend sticking with the Arduino name brand, that way we know we're on the same page. You're also going to need a 10K resistor. So the lines on a 10K resistor, you should have a brown one, a black one, an orange one, and then probably a gold one after that. You'll need a momentary push button, so that's a button that you press and then it pops back up. You're going to need about 4 jumper wires. That's what I used. You could probably use less. More wouldn't hurt either. And then you're going to need a solderless breadboard. So in order to set up the circuit, let's take a look at the schematic. So from the schematic, you should be able to set up the circuit on your board. And so what the colored lines represent, those are just jumper wires that we talked about before. So here I've got a jumper wire going from 5 volts to the breadboard. And it goes to that line on the breadboard where there's a red line that runs horizontally across the picture here. And that means that that entire line is electrically connected and it is going to be carrying the 5 volts. So it's like creating a 5-volt bar on your breadboard. And then you notice I do the same thing with the ground. So I take the ground from the Arduino board and I move it up to the breadboard. And so then that whole blue line is now ground. So that is the ground and the voltage, the 5 volts that I've set up on the breadboard, and now I can connect to that. So the first thing after that is I'm going to take a jumper wire and run it from pin 2 to one side of my push button, and here it's the right side. And then I'm going to take my 10K resistor and I'm going to hook it up to the ground bar on the solderless breadboard. Now on the other side of the push button, I run a wire to power to the 5-volt line. So let's just quickly talk about this circuit here. So if I'm not pressing the push button, what kind of voltage is pin 2 exposed to? Well, you can see pin 2, it's connected to the right side of that push button. And if it can't get to the left side of the push button, that means it's going through that 10K resistor and it's going to ground. Because you can see it's connected to that ground bar. So if I'm not pressing the button, the right side is connected to ground. So that means 0 volts is going to be seen, quote unquote, seen by pin 2. Now what happens when I press the push button? Well, when I press the push button, now the 5-volt power is now it's going to be exposed to pin 2. So now pin 2 is going to go high. It's going to go to, it's going to register 5 volts because now it's being exposed to the 5 volts from the Arduino. So I mean, that's just kind of a rough idea of what's taking place here. So when you're not pressing that button, it's 0 volts, and when you are pressing the button, 5 volts is being seen by pin 2, and that's what it's registering. Okay, so that's pretty much the circuit setup. Let's go ahead and jump into the sketch. Alright, go ahead and open up your Arduino IDE and go to File, Examples, Basics, DigitalRead Serial. Alright, let's go ahead from the top of the program and look through. So the first block of code we come to is a multi-line comment. So the multi-line comment here, it gives a short description of the program and the circuit. And then also note that it says that the example code is in the public domain. So that pretty much tells us that we can use and reuse and modify this program however we feel appropriate. And it is always a good habit to read the comments. So I recommend developing that habit as you continue to program and as you continue to mess with Arduino. Alright, so let's move on to the next block of code. That's generally where we will declare and initialize variables, and this sketch is no different. So here we're making a variable, and oh hey, it's our familiar friend integer. So it's int, and notice that the color's orange, and we know that's why, because that's a data type, and which means it's a keyword for Arduino, so it turns orange. And then we've got a name here, push button. Push button, that is like music to my ears. It's a very descriptive name because push button is where we physically are going to attach the pin for the push button. That's what when we set up the circuit, we put the push button at pin 2. And look at that, they've initialized push button to 2. So great example of a descriptive variable name. Okay, so first off we note we've declared and initialized all in the same line. So that's pretty much it. That's all we had to do. And there was only one variable here, so that's a pretty easy block of code. And then just note that semicolon finishes up that statement. Okay, well let's move on to the next block of code. The next block of code we come to is the setup function. So inside these curly brackets, there's two functions. There's serial begin, and then there's pin mode. So let's go ahead and talk about serial begin. This is a function that you will learn to love. Alright, so let's take a step back. It's kind of a weird looking function, isn't it? There's a period in there, and why is there a period in there? Well, that's because this is actually a function that comes out of a library of functions. And a library is really just a family of functions that work together towards a similar purpose. So if you had like a circus library, it might contain functions like juggle or balance and maybe like flaming circle of death. So to access the functions in the library, all you do is you write the name of the library followed by a period and then the name of the function that you want to get from the library. So with the circus example, we would write circus.juggle, for example. So we would want the juggle function from the circus library. So Arduino has many built-in libraries and many community contributed libraries. So that's people like me and you who we wrote a bunch of functions to solve a certain problem. We wrap them all up in a library, and then we say, hey, this is what we did. Anybody else is welcome to use those functions too. So as you can imagine, that becomes really useful, and you get this huge pool of libraries that you can pull from, so you don't have to recreate the wheel. So you can check the libraries out on the Arduino website, or you can Google for a specific library, and you'd be amazed at what you can find. What really does the serial library do? So what the serial library helps you do is establish communication between your computer and the Arduino board. So if you ever go to marriage counseling, you will know that communication involves sending and receiving. So data can flow both ways. And if you want to establish this communication between your Arduino and your computer, then you have to use the begin function from the serial library. The begin function takes one argument, so that's the number that goes in that parenthesis. Remember, that's called the argument. And the argument here is the baud rate. Okay, so baud rate, that means nothing, maybe. I mean, what does that mean, you ask? So it's the rate at which data is going to flow from your computer to your Arduino. And I'm going to give you the short answer right here. Just type in 9600. That's really all you need to know. And I know that seems like I want to know why. I mean, why am I typing 9600? Well, I've put some links on the end of the tutorial, on the written version. So I know you have an insatiable desire to understand all things in the universe, and I totally appreciate that because I'm kind of the same way. But it's just not what we need to talk about here. I just want to move on with the program, but there are links to say why you would type in 9600. But again, basically what we're doing with the serial begin function is we are establishing serial communication between your Arduino and your computer. That's why this line of code is in here. Because what we're going to do is we're going to let the Arduino tell the computer, hey, this is when that button got pressed. And in order to know that, we need to have that serial begin function. All right, so enough about serial begin. Let's move on to our next function, pin mode. Hey, wait, pin mode? We know pin mode. We used it in the last tutorial. So what's cool about pin mode this time around, though, is that now we're, instead of making the push button an output, we're making the push button an input, because we want to read voltage on digital pin 2. So again, we send two arguments to pin mode. The variable name, push button, which is pin 2, that's where we have our push button attached. And then what is the mode we want? Well, we want it to be an input. And we want it to be an input because we need to read voltage from the digital pin. Okay, so that's all that's going on in the setup block of code. So the next block of code is the function loop. And so what do we see here? So the first thing we run into, int button state equals digital read push button. Now what the heck is that? I mean, it looks like they're declaring a variable. So I know we said that that usually is going to happen at the top of the sketch. But actually, we can declare and initialize a variable anytime we want in our program. And we're going to see here shortly why this is the way to go. So let's break down this statement. First, let's look at the data type and the name. So we're declaring an integer and we're calling it button state. So I bet you can guess what this variable is for. It's going to hold the state of our push button. Great descriptive name. Now to initialize the variable, we see something altogether new and awesome. What we've done is we're setting the variable equal to the output of a function called DigitalRead. So now this is going to take a little recall power on your part. Do you remember the reason of the word void in front of the loop function? So we had to write void because the function loop does not return a value. But that's not the case for the function DigitalRead. The DigitalRead function actually returns an integer, so either a 1 or a 0. So it will return 1 if the voltage at the pin that you specify is high, and it will return the value 0 if the voltage at the pin you specified is low. So, well, what pin? Where are you coming up with a pin? Well, that's the pin that you pass as an argument to the DigitalRead function. So in this case, we send the variable push button. And because we want to read the state of pin 2, so if you recall, push button was initialized to equal 2 at the beginning. So again, all of that is in the file, in this line of code. Int button state, so we're declaring the variable. We let it equal the output of the DigitalRead function push button. So I mean, this is why Arduino really rocks, and really why the C programming language rocks, is because in one line of code, you're pretty much on your way to dominating the world. I mean, it's really easy. So now the state of the push button is either going to be high, so that's when you're pressing the button, or low, and that's when you're not pressing the button. So if the state's high, that's going to report a 1, and if the state's low, that's going to report a 0. So if I'm pressing the button, DigitalRead is going to return the number 1, and when we come to this statement in the loop function, the button state variable is going to be initialized to the number 1. Now if I'm not pressing the button and the program comes to this line of code in the loop function, button state's going to be assigned the value 0. That's really it. It's pretty cool. So when we press the push button, what's happening on the Arduino board is pin 2 is being exposed to the 5 volts from the Arduino board. And so that 5 volts is considered high. And then the DigitalRead function, like we just said, is going to return the value 1. And then if the button is not being pressed, then all that pin 2 is going to be exposed to is the ground voltage, which is 0, and DigitalRead is going to return a 0. So I hope that's clear as mud. Okay, so we've just recorded the state of digital pin 2. It's either going to be high or it's going to be low. So high is going to be a 1, a low is going to be a 0. So how do we see that information? What if we want to know what the state is? Well, I mean, we would kind of know because we're pressing the button. But what if we wanted to see it on our computer screen? Well, we would have to communicate that to the computer from the Arduino. So in order to communicate that, we need to use one of the functions from the serial library. And we can use one of the functions from the serial library because we already set up serial communications with our serial begin function call in void setup. So now what we're going to do is we're going to use another function from the serial library called printline. And what printline does is it prints the variable or the words that you put in the function, that you pass to that function in the serial monitor. So that sounds kind of weird. So what have we done here? So we've got serial printline button state. So button state is the variable that we just set. So button state's either going to be a 1 or a 0. So what printline is going to do is it's either going to send the 1 or the 0 to the serial monitor. Well, what is the serial monitor I keep talking about? Well, just go ahead and go to Tools, Serial Monitor, and it opens up this screen right here. It's got a lot of white space and some other information on it. So let's go ahead and review let's go ahead and figure out what the serial monitor is exactly. So what the serial monitor does is it looks at the serial port that your Arduino is connected in, and then it's going to display information that's passing back and forth. So if we are sending a 1, then the number 1 is going to come up here. If the Arduino is sending a 0, the number 0 would come up here. Whatever the Arduino is sending, it's going to come up on the serial monitor as long as you're printing to the serial monitor. Okay? So let's just take a quick look. Up here we see this address here, this path address. And what this is the address that your Arduino is hooked up into. So on a Mac, it starts with like a TTY, and it's got like 411 at the end. That's generally what you'll see when you hook your Arduino to a Mac. With the PC, you generally see COM4. COM port 4 is what comes up. That's not always the case, but that's usually the case, and it's really pretty generally just self-recognizes, but that's a good place to start. So down here we see the baud rate, again 9600, that's what's specified, and we can pick other ones, but remember 9600 is where you want to go. And then they've got both new line and CR, which is carriage return. The NL is new line and CR is carriage return, and then no line ending. Basically this just talks about how the information is going to get displayed. So do you want the zeros or the information to go long across the screen and keep repeating, or do you want like a line there so it comes this way and comes down? And then the auto scroll function, this little button here, a bunch of information is going to be coming from your Arduino. So do you want it to keep following the new information, or do you not want it to follow the new information? That's basically what auto scroll does, and it will become readily apparent once we actually have some information coming across. So that is the serial monitor. Again, it allows you to see information coming from your Arduino. Now, we haven't talked about this send up block up here because we're going to talk about that in a different tutorial. But this is how we would send information to our Arduino from our computer. So let's recap what we've done through the loop so far. The first thing is we've declared the button state variable, and we've set it equal to the output of the DigitalRead function. And the DigitalRead function is reading the value at digital pin 2. So it's either going to be high voltage or low voltage. And DigitalRead is going to report back a 1 for high voltage and a 0 for low voltage. And then once we have the button state, we print that using the printline function from the serial monitor, and we print it basically to the serial monitor. And so we're able to see either a 1 or a 0 at the serial monitor. And then the final thing we do in the loop is we delay 1 millisecond, and that just allows stability in between the readings. So if kind of that transition between pressing and not pressing the button there. And then the loop goes over and over again, so it's constantly checking for the state of that button, and then it's going to change what it shows on the serial monitor based on whether you've maybe stopped pressing it or started pressing it. So let's go ahead and verify the program, and we'll upload it. And now we can come to Tools, Serial Monitor, and now we can see we see these zeros coming up. Now if I stop pressing auto scroll, basically you can see the slider going up here because all those zeros are getting added up here. But if I want to catch back up, I go back to auto scroll, and now the most recent value is being shown there. And we'll go ahead and I'm going to go ahead and press the button. Let's see what happens. Oh, look at that. It's all ones now. So the voltage is high. Remember, 5 volts can now be seen by digital pin 2. When I press that button, now I'm going to release. What happens? 0. Now ground voltage is being seen by pin 2. So it's just pretty awesome in my opinion. Okay? Zeros and ones. Alright, well, that pretty much closes up this tutorial. I really hope you decide to do the challenges at the end of this tutorial. I think it's going to really kind of stretch you and help you figure out what is taking place in this lesson. And I apologize for this thing being so long, but there was just a lot of good information to pass on. So there you have it. I can't wait to see you in the next tutorial.